We've done a number of problems with equations of motion where they start us off with the acceleration, and from there we had to integrate to get the velocity, and then integrate again to get the position. This one's easier because they start us off with the velocity. It means we only have to do one step. So if our velocity, which is the first derivative of position, is 2t minus 1, then the position itself would be the antiderivative of 2t minus 1. If you skip this step, I don't blame you. I normally don't do it myself. I'm just writing it out to remind you what's happening. But really, if you're doing this, you'd probably go straight to the antiderivative of 2t is t squared. The antiderivative of minus 1 is minus t, and then we get an unknown constant. So that's our position function, and it's done except for this bit. They tell us that, oh, okay, I spoke too soon. They don't actually tell us what this c is. So we don't know our starting point. That means we know how this function behaves as far as movement, but we don't know what our initial position was. And now, in addition to that, they ask us something new. Find the distance traveled by the object from 3 seconds to 5 seconds. Well, that's not terribly hard to do, although it takes a little bit of number crunching. What we have to find is where are we when the time is 5, and where are we when the time is 3, and then we'll see how far apart those two positions are. So S of 5 means 5 squared minus 5 plus, it's sure not nice having that c in there. But the good news is we can solve this anyway. This c looks like it's going to be the death of us when we try to find positions, but something good is going to happen actually. So we'll just carry on with that, deal with the c as best we can. 5 squared is 25. Take away 5, you get 20. So our position after 5 seconds is 20 plus c. In other words, 20 meters north or to the right of our starting point. After 3 seconds, we go back to our position function. We get 3 squared minus 3 plus c equals 9 minus 3 is 6 plus c. So those are our positions at 5 seconds and at 3 seconds. If you want to know how far you've moved between these two, you subtract them. 20 plus c minus 6 plus c, and look what happens. 20 minus 6 is 14. C minus c is 0. So the c's were hanging around and making this thing look lousy, but in the end they canceled out, and we were able to answer this thing even without knowing what the c is. Those 2 points are 14 meters apart, and it turns out that makes sense, doesn't it? If you know how fast you're moving, you don't need your starting point to know how far you're going to move in 2 seconds if you know everything about your motion. It doesn't matter if this is 1,006 and this is 1,020, or if this is 6 and this is 20, or 106 and 120. Either way, it's a 14-meter displacement, and the math understands that. It understands that this c is irrelevant, and it cancels it out for you, saying it's okay, even if you don't know this starting point, I can tell you the answer you're looking for.